Okay, so in the last video, we have discussed about the motion of a car on a level road. So in this video, we'll discuss about the motion of a car on a banked road. So level road means in a plane-like situation, the car is moving in a plane track, in a circular track, or in a turning point like a curved path. So in that, uh, if the car is moving in a circular path or at a turning point, with what maximum velocity it can move, we have calculated, and we have calculated that for a curved path, and if the level and if it is a level or it's a plane like situation, then having a radius r, the car can move with a speed v is equal to mu s rz on the root, v max you can write. So we have derived this in our last class. So in this class, we'll discuss that what can be the maximum speed, or with what maximum speed you can take a turn on a banked road, on an inclined road. If the road is not level, slightly inclined, then what can be your speed? Is it same, or with will the velocity, will the maximum velocity will be more? So let us see mathematically. From our general experience or from our common sense, we can say that if the level is, if it is a little inclined road, so we can travel with a more speed because there are less chances of slipping or of your car, okay, from the track, because it's a slightly bent road or inclined road. So now let us mathematically check what are the forces acting on these cases, and how you will write and solve this equation to finally get the velocity. Okay, so let us go to our discussion. So here the road will be slightly bent with certain angle. The road will be like this. Okay. Okay. So it has certain angle. It's slightly curved road. So in this road, if a car is taking a turn, moving like this, and taking a turn with a moving with a velocity v and taking a turn, so what will be with what speed it can take the turn, or what can be its maximum speed? So before we calculate, let us first calculate what are the forces acting on this car. As in our previous discussion, that is for a level car, we have discussed all the forces which are acting on the car. Here also we'll discuss what are the forces that are acting on the car. As you can see clearly, this is a situation like inclined plane case where the car is here or an object is here, okay, but it's not moving up. You can say the car is rather moving in this direction, okay. Car is here, moving in this direction. So the moment of velocity of the car is in this direction. So what are the forces on this car? You can see, obviously, the car has some mass, okay. So due to the mass of the car, the weight will be downward, and this will be, I can write mg. Now, as the car is moving, okay, so it will have some, in a circular path or in a track or a turning, so it will have a necessary centripetal force, which will be provided by component of force, friction, not just friction, because friction will be here. Friction is along the surface only. Here is the friction, and normal is here to 90 degree. This is your normal. Very carefully look. Yes, friction provides, but friction not exactly friction. The component of friction provides the necessary centripetal force. Okay. So if this is theta, this will be theta, alternate interior, and this will be this is 90. So you can write this is your centripetal force, which is F is equal to mv square upon r, and this component of F here I can draw also. Okay, one perpendicular. So now what you can do, if you may not draw it also, but if this F vector, that is friction, the component of the friction on this mg and along the mg direction, okay, if we'll take this coordinate, this is perpendicular, right? So F vector along mg will be F sine theta, and yes, you can take this one, and this one, these two coordinates. Okay, so F vector along mg is F sine theta, and F vector along your centripetal direction, along the radius direction, this will be F cos theta, right? And if we'll draw a perpendicular here, then this is your normal, and this angle will be again theta. Why? Because this is theta, here 90 degree, this is 90 minus theta, and if 90 minus theta, this is again 90, so 90, this will be theta. You can do the rough work, and you can do it. Let me draw it clearly for you. So this is your inclined plane on which the car is here. Okay. So mg will be downward, friction is along the surface. Okay. Now normal is always perpendicular to the surface. Now this is the direction of your car will move like this now. So it is the car is covering this track radius, so centripetal force direction, ये center के तरफ direction है, centripetal के तरफ, ठीक है? So this is the direction towards the centripetal. So we have to bring all the forces in this direction only, centripetal force direction. Okay, then only we can compare it with mv square upon r with this one. Okay, so that's why we have chosen this axis, not this axis. So we have chosen this one is your x-axis, and this is your y-axis, you can say, imagine, right? So if this is your bent rod having angle theta, then this angle will be theta. Alternate interior is your parallel, this is your transversal, so this one is alternate interior theta. Again, this is 90 minus theta, and this angle will be theta. So n, component of n along y-axis will be n cos theta. Component of n along the centripetal direction, centripetal force direction towards the center is n sin theta. Component of f along mg is f sin theta. Component of f along your centripetal force direction, that towards the center, that is f cos theta. So what are the forces along the centripetal center? Okay, what are the forces? Now n sin theta and f cos theta. So we can write, and this is providing the necessary centripetal force. Very important. This force is providing the necessary centripetal force to keep the car on the track. Okay, so can I write that n sin theta plus f cos theta is your necessary centripetal force, that is mv square upon r. I can write. Okay, so this is one equation. Now one more equation I can write, this one I can, because there is no motion along y direction, there is no motion along y direction, so I can write that mg plus f cos f sin theta, this one, two downward forces, they are balanced each other, sin theta is equal to n cos theta. So these are the two equations in our hand, right? One is from comparing the y and another is towards the x. No other force. We have now this f and n, इसको component form में उसको resolve कर दिया already, तो उसका कोई भी जरूरत नहीं है अभी, ठीक है? ये सब resolve already है, इसको इसके ऊपर इसके ऊपर सब resolved हो गया, तो ये force अभी नहीं है, ठीक है? So whatever force we have resolved into x and y, now we can write them in equation form. Now we'll solve it and find out the v here. Easily you can do. So how we'll do? Okay. So we can find out first the n. Okay. And also we have to find the f in terms of your mu n. So we can write that f is equal to mu s n, you know, that is for b max we can write mu s n, so we can write that, here I can write the relationship between f and mu n. So mu s is equal to mu s n is equal to f s, or this is maximum. For maximum case we can write mu s n, or less than equal to we can write. Okay, for maximum we can write mu s n. So if we use here and we can remove all the frictions, we can write in terms of mu s n. So I can write mg plus mu s n sin theta is equal to n cos theta, or I can take here, so I can write mg equal to n common cos theta minus mu s sin theta. I have taken this term to the right side, right? So I can write n is equal to mg upon cos theta minus mu s sin theta. So I can do that. Now what I'll do, I'll just put this value of n in equation 1 to find out the v square. What is our target? Our target is to calculate the maximum speed with what should be the maximum speed of your car during the turning. That is our target to calculate. So we will calculate Vmax here. Okay. So let's do that. So let's do that. Now this is n, so I can put here, and I can also do that. Okay, let me write first. So n sin theta plus, I'll replace this f as mu s n. Mu s n cos theta is equal to mv square upon r. So I'll take common n sin theta mu s cos theta is equal to mv square upon r. Now I'll replace n, that is mg sin theta mu s cos theta by cos theta minus mu s sin theta is equal to mv square upon r. Mm cancelled, right? Mm cancelled. Now you can find out v square. ये r को इधर ले आएंगे लेफ्ट साइड में, सो v स्क्वायर विल बी इक्वल टू rg. अच्छा, इधर क्या करेंगे, और एक cos थीटा डिवाइड कर देते हैं बोथ साइड, इधर एक cos थीटा डिवाइड कर देंगे और इधर भी एक cos थीटा डिवाइड कर देंगे, तो क्या हो जाएगा sin थीटा बाई cos थीटा, tan थीटा, cos थीटा बाई cos थीटा कैंसिल, म्यू एस डिवाइडेड बाय नीचे क्या हो जाएगा cos थीटा बाई cos थीटा कैंसिल, 1 माइनस म्यू एस tan theta. So this is what you are getting V max. Okay, this is what you are getting V max, that is mu s plus tan theta. This is your V max. Okay, so let me just write one conclusion that we are getting the V max is the maximum velocity of your vehicle on a banked road is your RG mu s plus tan theta by 1 minus mu s tan theta to the power half means root over. Okay, so this is what we are getting. Suppose the friction is not there between the tire and the road, it's a frictionless, let's say, still you can travel with some speed because of the banking, because of the theta angle, because of the banking of the road, you can still travel with some speed. Okay, so what speed you can travel? Sometimes in the exam this question comes also. If there is no friction between the road and your vehicle, can we travel, or what speed we can travel? So if your mu s, that is frictionless surface, mu s is 0, imagine mu s is 0, then what will be what you will get velocity, the V max you can get RG, ये 0 हो जाएगा, नीचे in the denominator 1, so denominator 1 means there is nothing in the denominator, I can write mu is 0, so RG tan theta half. So this will be V max. If it is a frictionless surface, even you can move with this much of velocity. Okay, so this is the derivation for maximum velocity on a banked road. Very important here is to draw the free body diagram and resolve the components in proper manner. That is very important. Sometimes the students get confused how to resolve these components. So resolution of components of the vector is important in this case, and to compare the centripetal force, compare it with the centripetal force. So here you can see that in case of a banked road, exactly the friction is not providing the necessary centripetal force, but a component of friction is providing a necessary centripetal force. One component, not exactly the friction. F cos theta is and plus n sin theta is providing the necessary centripetal force. दोनों मिलके provide कर रहे हैं. Not on single friction is not providing. But in case of a level rod, if you remember, in case of a level rod, the only frictional force is providing the necessary centripetal force to keep the object on the track or on a circular path. Okay, so this is the difference, and try to solve few problems in my next video if possible. I'll solve some numericals based on these concepts. These are very important. Many times these concepts comes in your NEET and JEE exams also. So anyway, some other questions I'll discuss in the next video. Thank you.